Hello, everybody. I think we can start. This is the session about reactive programming and how to deal with asynchronicity. My name is Ricardo Sanz. I'm a Drupal developer and DevOps since I think I have been doing this for 10 years. You can find me on Drupal.org. My username is Tunic, and in Twitter, I'm Sanz Ante. I'm one of the founders of Metadrop, a Drupal developer company based in Madrid, Spain. And well, that's all about me. Let's wait a little bit. Sorry.
It's recording.
Should I start again?
No, it's fine.
Okay. So the walkthrough of this talk, it's here. We are going to talk a little bit, a little intro about the reactive programming. We are going to talk about the approaches to deal with asynchronicity. Then we'll talk about reactive programming more deeply. Then plumbing, because reactive programming is about creating plumbing system for the data. Then we'll talk about observables and operators. That are the two basic components of the reactive programming. There are more, but those are the minimum you need. And then we'll see some code examples and some final notes. So let's go. The introduction. Reactive programming, it's a way to manage asynchronicity. This is not a talk about React, because sometimes someone thinks it's React, but it's not related at all to React. This talk is based on the ReactiveX library. There are other libraries that implement reactive programming, but this is the more used. And in this library you can use it in JavaScript, but also in other languages like PHP, Java, Scala, C#, C++, Python, etc. The main advantages of the reactive programming, it's that it greatly simplifies the work with asynchronous sources. It's very easy to combine different asynchronous data sources and generates a code that it's shorter, cleaner, and more intuitive than other approaches. I have used an asterisk in this sentence because it's true, but you have to deprogram yourself a little bit from the structured, object-oriented programming to understand how reactive programming works. Once you have done this, it's very easy to read. All of this leads to a code that is more maintainable. So I think there are good advantages, especially taking into account that the asynchronicity is something very hard in computer science. And what is the asynchronicity? Well, we can say that there are events that happen over time that we can't predict. This is very common in the browser because it's an asynchronous environment. On the other side, if we examine, for example, a Drupal request, we find that the execution path it's more or less predictable. It's complex, but it's more or less predictable. And the data, it's available when you need it. For example, when you query the database, the response, an error or a success, it's available on the next line of code. You don't have to wait for the response. In the browser, this is not true. There are many operations that are asynchronous, like Ajax operation, for example, are the typical example. It's the same for workers, for WebSockets, the user interaction, the timers or animation. There are all sources of data that are not predictable. You don't know when they are going to happen. So how we can manage this uncertainty, this asynchronicity? Well, that's the next part of the talk. We are going to talk about how to deal with the asynchronicity, the different approaches. that you can use. The first one is the classic one and the simplest. It's using callbacks. They are simple reaction to an event. So when an event is received, a function is called. This function processes the event and its data. And the typical example are the listeners. For example, click listeners. When the user clicks something else happens. For example, here the user can click the grip element, and then a panel moves. The callbacks are so simple that they don't allow many possibilities, and code complex reactions is very hard, and things start to get complicated when you, for example, you need to process data inside a callback, and you need more callbacks to process that data. And this usually leads to the callback hell. You probably may have seen code like this. It's a nested code because of the successive callbacks, and this code is not easy to read and to follow the flow. It's not clean and it's not elegant. And so, what was the solution to this problem? The solution were the promises. The promises were introduced to the standard in ECMAScript 6. They greatly improved the flow and the error management. They were a big improvement. And they basically grab asynchronous operations and react when there is a result. You can say that they are almost callbacks turned into objects. That's not really true, but it's a way to understand them. They were a big improvement. People were very happy with them, but they have certain limitations. The problems with the promises are that they are only resolved once. They return a single value. That means that if you need to deal with some asynchronous operations, each time you expect a value, you need to set up the promise. This can be solved using a function that sets up the promise, but at the end you need a certain code control to set up the promises. The execution flow of a code using promises is not always easy to read. There is, for example, a great article from the creator of the PouchDB talking about how to read the promises, and it's very interesting because they are not intuitive. When you know them very well, maybe, but if you don't, they are sometimes hard to know what is going to happen. They are not lazy and they are not cancelable. So when the promise is created, the code that tries to solve it's executed immediately. It's assumed that the answer is needed immediately, and because they are not cancelable, you can't cancel them. There are some libraries that allow this, but in general, you can't cancel the promise. So the resources that they need, they are being used. And you can fall in the promise hell, that it's code similar to the callback hell, but using nested promises. So they are a very good piece of code or approach, but for really complex interaction, I think they are not enough. So the next approach is using the reactive programming. It's hard to define the reactive programming. There are many definitions, and not all are good enough. You could say that it brings functional capabilities to imperative programming, as we will see in the next slides. You could say that reactive programming is using asynchronous data streams Or you can say that reactive programming it's to declare data pipes that process and transform the data that cross those pipes. Or you can say that it's just a declaration of reactions to changes. In some way, a simple example, it's how Angular Reactor View updates the screen. When the value of a variable is changed, that value it's updated on the screen. It's something that you don't need you don't need anything to do. I mean, you don't need to do anything to have that change. It's something that the framework does. It's a reaction and change. When the variable changes, the data is updated. So, how do you use the reactive programming? Well, the most important concept is the plumbing. As I said before, you have to create a plumbing system for the data that the data crosses and it's transformed and at the end a reaction it's done. So you have to create the data pipes. The pipe transform and manage the data in different ways, and at the end of the pipe, our reaction is triggered. So, what will be a simple pipe? The most simple pipe, it's something that you have done probably many times. It's just the click event listener. In this case, it's the same example as before. It's very easy. It's an event listener on a click element, on a click event for an element. The data source is the click event. When the user clicks, there is a data that starts to cross the plumbing system. And at the end of the plumbing system, there is an action. In this case, just a panel is moved. In this example, there is not really a plumbing system because it's so simple that the data source directly goes to the action. Okay, but that's because it's the simple pipe example. What would be a complex pipe? This can be a complex pipe. You have a data source, different transformations, and an action. For example, when the user clicks an item, button for example, an Ajax request is made, then the data is retrieved, converted into instance in instance, and then assigned to a variable. For example, I don't know, getting the list of something from an external API. In this case, the mouse click, it's converted into an URL, then the URL into the content into objects, and then assigned to a variable. That's something that you have probably have done before with other approaches, but then later we'll see how to do it with reactive programming. And now this is the brief pause because we are getting into the reactive programming concepts that you need to understand to do the reactive programming. Okay, now it's when the things get a little bit thick. The two important things on reactive programming, or the two most important things maybe, are the observables and the operators. The observables, or you can see as streams, are, let's say that they're just things that can be observed. Boxes where the data comes from, and you can see that basically they are the observed part of the observed pattern. They are more than just data streams, okay? But I don't want to to get into more technical definitions. Let's say that they are just data streams, and they emit data until they finish or an error is triggered. think of like a pipe where sometimes that data it's emitted. The observables change over time, so they are difficult to visualize how they are behaving. Because of this, we have the marble diagrams. It's a way to express how observables are behaving. Okay, a marble diagram is something like this. It's a simple way to show the data flow over time. The first example is just a observable that emits 4 values. The first one is the A1, then a delay, then A2, and immediately the value A3, and later the value A4. And the vertical line is the end of the observable. At that point, the observable has finished and it's not going to emit anything else. The second observable, the second diagram, it's observable that emits 3 values and then stops because of an error. Okay. The marble diagrams are very important to when you are creating your programming system. Sometimes you need them to get understand clearly how it's working. Then we have the operators. The operators are the second fundamental part of the reactive programming. They allow the data to be transformed in more or less or complex ways, but also they allow to control the flow of the data. For example, they can prevent data from passing if the data doesn't match certain criteria. They also are able to create new observables. Well, the thing is that usually all operators, the output of the operator is a new observable. and then can combine streams. So, they are the way to manage the different observables. So let's see a couple of examples. They are very simple, okay? First one is the filter operators. That this operator just allows the values to pass the certain point or not, depending on the condition. In this case, we have a filter that only allows the numbers that are even to pass to the next stage. So the first one, the 3, it's rejected. 6 pass, 5 is rejected, and 12 and 2 they are passed. So I think it's just a simple operation. Another example is this one. It's some operator that transforms data. In this case, it's just a simple operation, multiplying it by 10. But you could, for example, I don't know, create an instance of an object from the data that you receive. Okay, now it's time for the code examples. The idea of those code examples is to first to solve a problem that you can solve with structured programming very, very easily, but this way you can compare the reactive programming and understand how it works, and then we will see more examples that I think are very, very interesting to do with reactive programming instead with other approaches. The first example is a chronometer. It's just a manual chronometer that accumulates time. There is a button to enable it, another button to pause. You have the example here. Let me show it to you. Okay. As you see, when we have loaded the page, this clock has started running, and this is the manual clock. I can enable it, so now it's running, and I can pause it and unpause. As you see, this is very simple to do in structured programming. but I think it's a good example for reactive programming. So the first thing you have to do is to create the plumbing system for this example. The plumbing system will be like this. We have one data pipe from the pause button to the toggle pause bar. It's simple. When you click the button, the variable is toggled. Then you have the tick data source from the clock, and the first data pipe, what it does is just to update the clock. Every time there is a tick, the clock is updated. And then that tick is combined with the start button, and with the and we use a filter operator to update the chronometer. So to start the chronometer, we need first a tick from the clock. Second, that the user clicks the start button. And third, that the the pause bar is enabled. Okay, do you understand it? Or does anybody doesn't understand it? Well, I suppose you do. So how we code this? Well, first we need a clock value. I mean a variable for the clock value. That's the one that's going to be incrementing. We need the clock on variable. This is, well, it should be the chronometer on. It's the variable that posts the chronometer. Then we have the first observable or data stream. It's the button start observable. When the user clicks the button start, this observable receives the event. Then we have the button pause data stream. It's the same. When the user clicks it, and an event crosses the data stream. Then we have another observable that it's the interval. It's the tick observable. So each second, a new value is introduced in the pipe. So one reaction to change. We subscribe to the pause button, and when we receive any value, we change the pause variable. That's a simple data pipe. Then we have we subscribe to the clock, and when there is a new value, we update the clock. This is this clock that it's running when we load the page. And then we have again the clock observable. We can subscribe to observables not only one but many times. So we create the pipe. We combine the clock with the start button, and then we filter the values. So if clock on is false, the data can't cross, and then we just subscribe. And when data comes to this step, we just increment the chronometer value. Okay, so as you see, it's a very compact code. No, it's not long, and you can describe the plumbing system very easily. Next example, Decathlon. I don't know if you know this game. It's a very, very old game where you have to click button very quickly to get your man run faster. So it's a button killer. We are going to program the code that detects the clicks in a row, double, triple, etc. The time is counted from the first click. Okay, the example. Let's see it. It's just this button, and if I click once, there is one click. If I click two clicks, and if I click like crazy, I get the different clicks. Okay, there are clicks in it's 2/3 of a second. So how I can do this? I think this is a good example because this is not so easy to do with structured programming, and with reactive programming it's very easy. First of all, I get the button element. I get the click. I create an observable from the click event. Then I grab the output element, and then we start to create our plumbing system. So from the click stream, I create a pipe. Then I create a buffer that with an interval of 2/3 of a second. And what it does, this operator, what it does is to group the different data that comes from the pipe in the 2/3 of a second. So it groups the data. Then I apply a map operator, and what I do is get the list of data I have received, and each item is a click of the user, and I convert from the list to the length of the list. So for example, if the user has done 3 clicks, I will change the 3 list items to just the number 3. Then I filter, I discard the single clicks, and well, I just subscribe to that stream. Okay, I receive the number of clicks, and then I append the number of clicks that I have received. In the example I have showed to you, I have added also a subscriber for 1 single click. That's why you can see the single click. But the code that detects the multiple clicks is this one. And just at the end, I just add a new data pipe with a delay of 3 seconds to delete the elements that I have added. So when I click something, then 3 seconds later, it's removed. Okay, using this part of the code. I subscribe, and then I just remove an element. And let's see another real, yeah?
Just one small question to that example. Could you technically also buffer the lowest pipe for 3 seconds and then remove all the text elements at once? Because now the text element 1 gets added, the second one gets added, and the first gets removed to the second.
The thing is that when an element is added to the output, at the same time, the data goes to the deleting pipe. So the idea is when an element is added, 3 seconds before it's removed. If you use a buffer here, I mean you could use a buffer, but I think in that case you will remove elements in groups. So well, I mean it could work, but it's a different feeling. So let's see a real life example. The one I have talked before, that the user clicks something, it gets converted to a new URL, get the contents, instantiate objects, and assigned to a variable. So we create an observable from the button, from the clicker event, then create the pipe. Then when a data gets there, I change the data, that the data is going to be an click event, but I don't care about the click event, just when it's received, and I change it, I transform into an URL. my endpoint, for example. Then I perform a request to that URL to get the contents of that URL. That's a list. Then I transform each item into a new instance, and then I subscribe to get the instance and assign them to a internal variable. As you see, it's just 1, 2, 3, 4, 5, 6 lines to do this task. But for example, let's say that you want to add an auto refresh functionality. Okay, auto refresh. So we start from the same, from the click event observable. We create our pipe, and the first thing we do is to merge that observable from the observable with the clicks with another observable that emits a value each 60 seconds. So at this point, after the merge operator, I'm going to have a new item when the user clicks or when 60 seconds has passed, and then the rest of the code. Get the URL, query the URL, instance, and assign. But let's say that we want to have the auto refresh optional. Well, no problem. First of all, we start with the interval observable. It's going to emit a value each 60 seconds. Then we create a pipe. Then we filter this observable with using a variable called auto refresh. So when the auto refresh is false, no values pass this step, this point. If it's true, the values are going to pass. Then we merge with the observable from the user click and just the usual code. And what about error management? Well, let's use another example, optional auto refresh and error management. Well, it's more or less the same. We have the interval observable, the pipe, we filter, then we try to get our data, and then we add catch, this catch functionality. And in this case, if there is any error inside the pipe, the catch is going to be executed. Think of obviously exceptions and try catch blocks. And what I'm doing here is just to return the same list I have now. So the experience from the user is just that nothing happens. The list is the same, but the error is not shown. It's not visible. So I think with those examples, well, you can more or less understand how reactive programming works and how powerful it is. I want to add some final notes. First of all, it's why using reactive programming. Well, because you can express a lot of things with reactive programming. For example, callbacks, they only express simple reactions, and promise not so simple, but they are simple as well. And using reactive programming, you are not going to nest the code, so you are not going to see any reactive programming hell or something like that. The observables, they emit values and more than one, not just one, so you can just set your plumbing system and it's working all the time without the need of setting it again like promises. The execution flow, it's intuitive. I think it's more intuitive than the callbacks or the promises, and well, you have to understand reactive programming to get it, to read it well, but once you understand it, it's very easy. Reactive programming is lazy. the values are only used when, well, try to be generated when you need it, and they are cancelable. You can cancel and observable whenever you want. At this point, some of you may think on the new functionality of JavaScript called the async function and the generators. I don't know if any one of you knows this. Do you know about generators? Well, it's a new functionality of JavaScript that allows in some way to create something similar to observables. You can say that you can use them to solve problems like you do with reactive programming, but I think that reactive programming it's much more rich and has a richer API. And let's say that the async function and the generators could be like the low-level solution, like reactive programming, but it's more hard to use. And when we should use reactive programming? Well, when you have many asynchronous data sources. Obviously, if you have a simple application with no asynchronicity, it's not worth to use it. When you have complex interaction with the user and the different components of your application, or complex interdependency, and in some way to avoid internal state because the observables, they really have internal state, but it's something that you don't deal with it. It's just something that the reactive programming deals with. So you can forget about keeping track of internal states. And at this point, I want to share my experience with an application I did in the past. This is the War Archery mobile application. It's an application for the War Archery Sport Federation. And well, you see different drop-downs on a list. The drop-downs, they are all dependent. The data of the drop-downs depends on the previous drop-down. The application had to work offline, so it needed some cache levels, local storage, and many other things. So this was very complex to program. The result is pretty asynchronous hell. I worked in this. Well, we worked in this first using AngularJS without reactive programming, and it was a nightmare. We lost some mental health in that time. And after that, Angular came out, and the Angular changed a lot from AngularJS, and they used the reactive programming. It's totally inside the Angular. So we did it again, but using reactive programming, and well, the difference was huge. Okay, and although it was hard because we had to learn the reactive programming, the asynchronous hell just became a complex but funny problem to solve. And a few observable notes. They are not just event emitters. They can be asynchronous or synchronous. They are very flexible. In this case, I have focused on the synchronous, but you can do it synchronous. They can be cold or hot. I could make a new talk about cold observables and hot observables, so I can't explain it too much, but it's about how they behave when you connect to them. They can be multicast or unicast, so you can subscribe to them many times, and the same data is delivered to all the subscribers, or each data is delivered only to one of them. And you can share or not the data source with the subscriptors. Those notes are just to remark that what I have shown to you is not just the surface, but there are many other capabilities of the reactive programming. And the last thing is why to adopt reactive programming. Well, the first reason is because there are many others that they have already done it. Those are companies that they are using now reactive programming. one way or another. And because, well, because why to allow it? Because it can express very complex models. It handles almost any data source. You can create an observable from wherever you want. They have been proposed for a standard to JavaScript. They are currently, well, in their way. I don't know if they are going to make it, but they are proposed. At the end, you get less code that you see in other approaches, so it improves the maintainability. It's available in many languages, so if you use reactive programming, for example, in JavaScript, you can apply to Java, PHP, or many other languages. And of course, you should or you may adopt it if you work with asynchronous environments. Here you have some links about reactive programming. The first one is a very interesting introduction to reactive programming. It's very interesting to read. There we have the interactive marble diagrams. Those are the operators of reactive programming, but interactive. So you can change the input data and see how they behave. You have the RX visualizer, that it's a tool to visualize the RX operators and observables. You have the link to ReactiveX library and the link to Ben Lesch's blog. That Ben Lesch is one of the core maintainers of the ReactiveX library, and he knows pretty well how they work. So he has very interesting articles there. And that's some questions. Yeah.
Do we have any performance advantages?
Sorry, performance?
Regarding, we get any performance advantages? We get faster than others, or
I don't have that information, but I understand that because the code that powers the reactive programming, it shouldn't be especially heavy. I think it should behave well in performative terms. Any other question? Okay, thanks. And a last word, as I said, I'm from a company in Madrid. We are hiring. If someone wants to join our team, we work in English and we work remotely, so you are welcome to talk to me. Okay? Thank you.